In section 6.3, we're going to talk about something called a matrix. And what a matrix is it's this array of numbers. Let's do it with an example. So something like 1, 2, 3, 7, 5, 1, 2, 2, 2. When we write a bunch of numbers grouped together in this way, we call this a matrix. In general, say we have something like A11 goes all the way up to A1n, goes all the way down here, and then we have AM1 all the way out here, AMN. So you see here, from this distance, from here to here, we're going to have m different things. Like here's the first thing, we count all the way down, here's the mth thing. So there's we can say m rows. If we go to the right, here's the first one, the 1. It goes all the way out here, all the way to the n. So we call these n columns. So a row goes in this direction, and a column goes down here. And what we say for this matrix, it's going to have order m by n, which is the number of rows by the number of columns. Okay, and so the only reason why we want to talk about matrices is that it's going to help us solve systems of equations like we've been doing in the past 2 sections. So before we talk about why that is true, first we're going to say how these two relate. How does the idea of a matrix relate to a system of equations? So in the previous several sections, we solved things like this. So say we have minus 7x plus 3y is equal to 4, and 8x minus 3y is equal to 6. So here's just the systems of equations that we had from the first section, chapter 6.1. So we can transform this to make it look like a matrix. And all we really do is just get rid of the equal signs and all these variables. So and what I mean by that is, say if we want to turn this, so turn into a matrix, all we do is, so we write these big parentheses, and all the numbers we see from the left to the right, we're going to write in here. So minus 7, 3, 4. And then 8 minus 3, 6. And usually what we write as well is to distinguish between like the left side of the equal sign and the right side of the equal sign. We put this line over here. So this right here turns into this. So this whole column, this is kind of like your x's. We had a minus 7x and an 8x. So in this column we have our minus 7 and our 8. These are just the numbers in front of the x's. And over here we have our y column. So we had 3y and a minus 3y. And then over here you can think of these as kind of like the answer. So this top one equaled 4, so we have a 4 up here, and this bottom one equaled 6, so we have a 6 down here. And so as far as turning a system, so like this, into a matrix, that's all there is to it. Another example, say if we have one with 3 variables, an x, y, and a z. So just making one up, we can have, x minus 7y plus z is equal to 2. And then maybe just this one down here, we're going to have a y plus a 4z is equal to 10. And then this bottom one, we can have an x plus 3z is equal to, let's do 7. So here's a system of equations. We have 3 equations, the first, second, and third. We have 3 variables we're solving for, an x, a y, and a z. This equation doesn't have an x in it, but that's fine. And this one doesn't have a y in it, but that's still fine. So if we want to turn this into a matrix, so again, we just look from the left to the right, and then we write the numbers in, just like how we did in this first example. So if we look in this first example, we had a column for our x's and a column for our y's. In this situation, we're going to have a column for our x's, y's, and z's. So we're going to have a little x column, a y column, a z column, and we're still going to have this line that represents these equal signs. And then over here, we're going to write the answers. So in this first one, we have 1x, so we're going to put a 1 here. A minus 7y, so we're going to put the minus 7 here. 1z, so we're going to put a 1 here. And then a 2. The next one, so we don't have an x, and whenever we don't have an x, we put a 0 there. So we're going to have a 0 for the x in the second one. There's a 1 in front of the y, and then a 4 in front of the z, and then a 10 on the equal sign part. This bottom one, we have a 1 in front of our x. We don't have a y, so we're going to put a 0 there. And we have a 3 in front of our z. And then it equals 7. So again, same thing. As far as just turning a system into a matrix, all you do is just write the numbers from left to right into this matrix over here. And we can also go in the backwards. Let's do just one little example like that as well too. So this is going from the examples we just did that we're given a system of equations and we're turning it into a matrix. So let's say if we have a matrix, how about like 1, 0, 0, 0, 1, 0, 0, 0, 1, and then on this side we're going to have, let's do 7, -2, and -5. So in this example, let's, instead of turning this into what already is a matrix, we want to turn this back into a systems of equations. Okay, so on the previous examples, when we had our matrix, this first column, that was always like our x's. The second column, that was always our y's. This third column, that was always our z's. This, the vertical bar, that kind of meant our equal signs. And then over here, these were the answers. And the numbers in here, these were the numbers in front of those variables. So for this first equation, we're going to have a 1 in front of our x, so just an x. Then we're going to have a 0 in front of our y. So just, we don't need to write this 0y, it's just equal to 0, but we'll write it for now. A 0 in front of the z, so plus a 0z, and that's going to be equal to this number 7. The second one, we have a 0 in front of our x, a 1 in front of the y, a 0 in front of the z, and that's equal to -2. And in the third one, we're going to have a 0 in front of the x, a 0 in front of our y, and a 1 in front of our z. And then that's going to equal -5. So what we just did there was we did the backwards of the previous example we just did. Here we turned from this matrix into the systems. But if you look over here, if we simplify this a little bit, so the 0y, 0z, so those just cancel out. And so what this ends up turning into is, well, the top is just going to be x is equal to 7. And the second one, the 0x goes away, the 0z goes away, so we just have a y. So we get y is equal to -2. And here in this third row, we have a 0x, a 0y, those go away, and we just have z is equal to -5. Which are sort of, these are our answers. X is 7, y is -2, z is -5. So what this tells us is that if we, so for example, this is the next problem that we're going to solve. And before we go to it, actually, let's keep talking about this. If we can turn our matrix to look something like this, we have our 1s just on this diagonal and 0s everywhere else, like here, and then just numbers over here. These numbers can be they can be 0, negatives, positive, doesn't matter what they are. Then this is going to give us the answers. So it's going to tell us that our x1 is going to be 7, our y is going to be -2, and our z is going to be -5, which is what we saw when we turned this into the systems and then simplified it. We just got our answers. X is 7, y is -2, z is -5. So say if we have a systems of equations. We'll do this one in a second. So -2x minus 3z, 3y minus z is equal to -1, and then -4x minus 2y minus 2z is equal to 2, and then 3x plus 3y plus z is equal to 1. So here's a systems of equations. We solved this one in well, not this particular one, but we solved an example like this in 6.2. In this section, we know now that we can turn this into a matrix. So if we turn this one into a matrix, so the top row is going to be -2, minus 3, minus 1, minus 1. You put the line here, minus 1. So this is your x column, your y column, and your z column. Our second row is minus 4, minus 2, minus 2, positive 2. And then our last column is 3, 3, 1, 1. So the whole goal in order to find x, y, and z is we want to know, can we do some things to this, like manipulate it and somehow turn it into a matrix that looks like this, where we have zeros everywhere on the bottom and on the top, and then just ones on this diagonal. Because if we can do that, we saw just by this top example up here, well then if we get the left side of the matrix to look like this, zeros, zeros, and ones, this will be your x, this will be your y, and that will be your z, which is what we see right here. So somehow what we want to do is manipulate this and have it turn into 1, 0, 0, 0, 1, 0, 0, 0, 1. And then over here, there's going to be some numbers. So number 1, number 2, number 3. And if we're able to do this, well, then this first number is going to be our x. So we're going to have, our x is going to be number 1. This number right here is going to be our y. Our y will equal number 2. And this third one down here is going to be our z. Our z is going to equal number 3. So our whole goal now is what can we do to manipulate this left-hand side to look like this? And so then these numbers over here, these are going to change as well. So whatever they change to, that's going to be our x and our y and our z. Okay, so let's go through that, how we can turn this into that. So just rewriting the problem that we want to solve. It was minus 2x minus 3y minus z is equal to minus 1 minus 4x minus 2y minus 2z is equal to 2. Then 3x plus 3y plus z is equal to 1. So this is the one we want to solve. And if you look back in section 6.2, our technique was to eliminate a variable in 2 separate ways and then combine those equations together to find one of the variables and to keep substituting those variables back in. So this is one that we did solve in 6.2. So now in this section, what we're going to do, the first thing is turn this into a matrix. So just on the previous page, we already did that. This became, the top row was minus 2, minus 3, minus 1, minus 1. And we have our line right here to represent the equal signs. So these equal signs are represented by this line. Then our second row is minus 4, minus 2, positive 2. And then we're going to have 3, 3, 1, 1. And so now what we're going to be able to do is, in order to turn this left-hand side into this, have it look like ones on the diagonal and zeros everywhere else, we're going to be able to take multiples of one entire row and add it to multiples of another row to somehow manipulate these numbers to become what they want. And there's a series of steps that are always going to work in our favor to allow us to do that. And the first thing is we want to figure out how can we turn this top left number into a 1. And then we have several choices here. Well, this top left number is a negative 2. So if we just take this entire first row and divide it by negative 2, we would have negative 2 divided by negative 2, and that would be 1. So that would give us what we want, this top left number to be a 1. But if we look at that, if we divide this whole top row by negative 2, then we're going to have minus 3 divided by negative 2, negative 1 divided by negative 2, but more importantly, we're going to have fractions here and we're going to have fractions here. And fractions are always hard to work with, so we want to try to avoid that. Another thing that we see we can do is, well, there's a 3 right here and there's a minus 2 right here. So if we add those two numbers, we get 1, since minus 2 plus 3 is 1. So the first thing we're going to do in this problem is, so we're going to manipulate this side, this whole equation now. And how we're going to do that is, instead of writing the first row down, we're going to write the third row plus the first row. That's going to be our new row 1. So that's what we're going to write right here. The next one, we're just going to keep row 2 to be the same, and then we're going to keep row 3 to be the same. The reason why we're keeping these two the same is the only thing we want to do right now is make this top left number a 1. That's our only thing that we're trying to do for this first step. And how we can do that is if we add, so here's row 1, here's row 2, here's row 3. If we add this row with this row, we're going to get this plus this, which is 1, and we're putting that new row up here. So we're going to have a 1 up here now, which is what we want. So up here, row 3 plus row 1. So this plus this, minus 2 plus 3, that's 1. Minus 3 plus 3, that's 0. Minus 1 plus 1, that's 0. And minus 1 plus 1, that's also 0. So there's our new row 1. It's 1, 0, 0, 0. Now our new row 2, or sorry, that's just going to be the old row 2. Just rewriting it, minus 4, minus 2, minus 2, 2, and then we're rewriting our row 3. 3, 3, 1, 1. Okay, so there's our first step. We now have a 1 in this top left position, which is what we want. The next step, what we want to do is now make everything beneath that a 0. And once we have there a 1 in this top left corner, that's going to be easy to do. So what we can do is, we don't want to manipulate the row 1. We're going to leave row 1 the same now. So this row 1 is the previous row 1. These always go with the previous matrix. So our new row 1, we're just going to rewrite our old row 1. And the reason why we don't want to change this row 1 is because we have a 1 up here, and that's what we want. And we want to have that be this, we want to keep that. So we want to keep having a 1 in the top left corner. So we're just going to rewrite our old row 1, 1, 0, 0, 0. So now we want to make, like we said a second ago, everything beneath this 1 we want to turn into a 0. So somehow we want to make this a 0, and then somehow we want to make this a 0. Well, we see here, if we take negative 4 and add it to 4 of this row, so 4 of this row, we're going to have this times 4, which is 4, since 4 times 1 is 4. We add those two numbers, this is going to go away. We would have minus 4 plus 4. So what I just said, just writing it down in like the numbers, we want to make this row 2. We're going to do row 2 plus 4 times row 1. So how we do that is we're going to do row 2, so minus 4, plus 4 times row 1. So minus 2 plus 4 of this. So 4 times 1 is 4. So this is minus 1 plus 4, which is 0. Now, minus 2 plus 4 of this. Well, 4 of 0 is just 0, so we're still going to have a minus 2 here. Minus 2 plus 4 of that. Again, 4 of 0 is just 0, so this is just going to be minus 2. And then 2 plus 4 of that. Again, 4 of 0 is a 0, so we're just going to have a 2 here. So now we have a 0 in this spot, but now we also want to turn this into a 0. And how we can do that is we're going to do this whole row 3, and we're going to subtract 3 of row 1. Since if we subtract 3 of row 1, we're going to have 3 minus 3 times 1, which is 3. So 3 minus 3, which is 0. So again, this spot right here, 3 minus 3 of 1, so that's 0. Now we're going to do 3 minus 3 of 0, which is still 3. Since 3 of 0 is 0, so we're doing 3 minus 0. So again, 3. 1 minus 3 of this, that's 1. And then 1 minus 3 of that, which is also 1. Okay, so now we have our next step completed. We have a 0 beneath all of, a 0 beneath the 1 that we made in the top left corner. So the next step is once we do that, so the first step was turn this top left number into a 1. The second step was make every number beneath of it a 0. Now the next step is going to make this number right here a 0. Oh, sorry, not a 0, a 1. The next number on the diagonal, we want to turn this into a 1. And so like we said in the first step, we can always just divide that entire row by this number. So if we take negative 2 and divide this whole row by it, we'll have negative 2 divided by negative 2 right here, which is positive 1, which is okay, but we want to make sure we avoid fractions. But if we look at these other two numbers, negative 2 divided by negative 2, that's also going to be 1. And positive 2 divided by negative 2, this number is going to be negative 1. So we're not going to have any fractions if we divide this whole entire row by a negative 2. So for that reason, what we're going to want to do is, well, one, we're going to leave row 1 the same. Again, we want to leave row 1 the same because we have a 1 in the top left corner. That's what we want. Our new row 2 is we're going to do row 2 divided by negative 2. And then we're not going to mess with row 3 right now. We'll do that in a second. Since we're leaving row 3 the same, because the only thing we want right now is for this to be a 1. Okay, so let's rewrite the old row 1, which is 1, 0, 0, 0. Now our new row 2 is row 2 divided by negative 2. So this divided by negative 2 is 0. Negative 2 divided by negative 2, that's positive 1. Negative 2 divided by negative 2, positive 1. And 2 divided by negative 2, that's negative 1. Okay, so now row 3, just we're rewriting it. 0, 3, 1, 1. Okay, so now once we did that step, we now made this number, the next diagonal number, a 1. We want to do that same thing what we did before, is make every number beneath this a 0. Just like up here we turned this into a 1, then turned this into a 0, and then this into a 0. Now we want to make this a 1 and turn that into a 0. And so we're not going to want to mess with row 1 right now. We don't want to mess with row 2, so we're going to rewrite those. And what we want to do for row 3 is we're going to take row 3 and subtract 3 of row 2, since then we would have 3 minus 3 of this, so 3 of 1, 3 minus 3, which is 0. So we're going to do row 3 minus 3 row 2. So here we're going to have row 3, 0 minus 3 of this, so 3 of 0, so we're going to have 0 minus 0, which is 0. We're going to have 3 minus 3 times 1, which is 0. And 1 minus 3 times 1, so 1 minus 3, which is negative 2. Now we're going to have 1 minus 3 of this, so it's going to be 1 plus 3, which is going to be 4. Again, so right here we have row 3 minus row 2, or 3 row 2. So we're going to do row 3, which is 1 minus 3 times this. So just writing that down, this number right here, which is 1 minus 3 times negative 1, which is 1 plus 3, which is 4. That's why there's a 4 right here. Okay, so now we have pretty much everything that we need to figure out what x, y, and z are. So if we turn this back into a systems of equations, this top row is saying that we're going to have 1x, so an x, plus 0y plus 0z, let's just write it in there, plus 0y plus 0z is equal to 0. Or in other words, just those go away, we have x equals, because 0y and 0z, that's a 0. So what we have here is x is equal to 0. Let's not mess with the second one now, but this third one, what this is saying is we're going to have 0x. We'll save the second one for here in a second. This third row is saying we're going to have 0x plus 0y minus 2z is equal to 4. Okay, well that does mean those go away since we have 0x, 0y. So this is telling us that minus 2z is equal to 4. But if we divide that minus 2 over, that's just telling us that z is equal to negative 2. Now what this second row is saying is we're going to have 0x plus 1y plus z is equal to minus 1. Okay, so then that 0x just goes away. So what we have is y plus z is equal to minus 1. But we know z, we found that a second ago, z was minus 2. So we're going to get y minus 2 is equal to minus 1. And if we add this 2 over, we're going to get y is equal to positive 1. And so now we have all three of our answers. We have x is going to be 0, y is going to be 1, and z is going to be minus 2.